MCA Prep Packet, day number 2. We're working on reviewing chapters 2 and 5 today, solving equations and solving inequalities. This should be on page 37 in your packet. Benchmark 8242. Solve multi-step equations in one variable. Solve for one variable in a multivariable equation in terms of the other variables. Justify the steps by identifying the properties of equalities used. Solve the equation 3x minus 5 equals 7. Part A. Show the first step towards solving the equation. What property did you use? This is a two-step equation. Our variables being multiplied by 3, then 5 is subtracted from that, and it has to be equal to 7. So our first step should be adding 5 on both sides. Remember, what you do on one side of your equation, you have to do on the other side in order to keep it balanced. So since I was adding 5 on both sides, that is called the addition property of equality. Part B, solve the equation. What property did you use? So my second step should be dividing by 3, because 3x means 3 times x, and the inverse of multiplying is dividing. Like on my first step, the inverse of subtracting 5 is adding 5. So I divide both sides by 3, and the result is x equals 4. So since I was dividing, I used the division property of equality. If you wanted to check your answer, remember you could always take x equals 4 and you could plug it in your original equation to make sure that you've solved it correctly. Where the x is, you substitute the 4 from your solution. 3 times 4 is 12, using the order of operations, and 12 minus 5 is 7. So my solution checks out. X does equal 4. The next page you should be on in your packet is 41. 8244 is our benchmark. Use linear inequalities to represent relationships in various contexts. George worked 8 hours at his part-time job yesterday. Let W represent his hourly wage. Part A, write an inequality that shows that he earned less than $125 yesterday. So he worked 8 hours, and his hourly wage, they chose the variable W to represent it. So if he worked 8 hours, I would need to multiply that times how much he is paid hourly. That's what hourly wage means, how much he gets paid each hour. So I would need to start with 8W. 8W. So if you think about this, if he worked 1 hour, 8 times 1, not 1 hour, sorry about that. If he earned, let's say he earned $5 an hour, because W is the hourly wage. If he earned $5 an hour times working 8 hours, that would be $40. But if his hourly wage was, say, $10 an hour, 8 times 10, he would get $80. It says on part A, write an inequality that shows he earned less than $125, so he earned less than $125. Okay, so he worked 8 hours at a wage that we don't know, but we know he earned less than $125. So that would be the inequality. It does not say to solve it, it just says to write it. Part B, write an inequality that shows he earned at least $75. So at the very least, he earned $75. So at least 75, if I have at least $75, I might have 75, 76, 77, and so on. At least means you've got 75 or more. So my symbol should be greater than or equal to. That's very tricky. symbol to remember. Because you see the word least, and it looks like the word less, but it does not mean the word less at all. So less than on the first problem means a less than symbol. At least means a greater than or equal to symbol. And it always helps me to think about money. If I have at least $75, that's the very least I have. I could have more. Okay, the next page. 43. Our benchmark is 8245. Solve linear inequalities using properties of inequalities. Graph the solutions on a number line. The properties of inequalities are just like the properties of equations. So as you're solving, I'm going to draw my train track, and I'm going to use the same properties that I would use if it was an equation instead of an inequality. For starters, I need to distribute the -4, so x, and then -4 times 3 is -12, -4 times positive 2x is -8x, like this. Then I'm going to put a 1 in front of the x that didn't have a coefficient, and these terms are on the same side and they are like terms. So 1x minus 8x is -7x minus 12 is less than 9. So that was just the first property I used, in case you're wondering about properties. That was the distributive property. The distributive property says that when something is being multiplied outside of parentheses, you distribute and multiply it times everything inside. Then I combine like terms because they're on the same side of my inequality. And now I am going to add 12 on both sides. So that is the addition property of equality. And then I will divide both sides by -7 and flip my symbol, because when you multiply or divide by a negative number on your inequality, in order to keep that inequality true, you have to flip your symbol. So that's the division property that I use of equality or inequality. And my solution is x is greater than -3. On a number line, remember that -3 would be to the left of 0. Greater than means an open circle because it's not equal to -3. It's greater than -3. So I'm not including the -3. And then the numbers are greater to the right on a number line. As you move to the right, the numbers are greater. Remember that the arrow right here on my ray matches the direction of my inequality symbol as long as the variable's on the left-hand side. So since I have x on the left-hand side greater than -3, the direction my ray is pointing matches the direction the inequality symbol points. So graphing an inequality means graphing it on a number line when it's an inequality in one variable. Our last benchmark for today, this should be on page number 45, 8246. Represent relationships in various contexts with equations and inequalities involving the absolute value of a linear expression. Solve such equations and inequalities and graph the solutions on a number line. Number 1, part A. Write an absolute value inequality that represents all values that are more than 2 units away from 5, and then solve it. And part B says graph the solution from part A on a number line. Okay, so we are looking for all values more than 2 units away. So greater than 2 units away from 5. And we are going to need absolute value here. The distance away from something, you can express as a difference, subtraction. So, in my absolute value bars, I believe I should have x minus 5, the distance away from 5. So for example, the distance that 7 is away from 5, 7 is 2 away from 5. I could also say the distance that, let's say, 9 is away from 5, 4 units away. Or 20 away from 5 is 15 units away. So subtraction is how we would find the difference between two numbers. So the absolute value of x minus 5 is greater than 2. That's what I believe we should be solving. Now, my number line down here, I'm putting 5 in the middle. Because if we're talking about being more than 2 units away from 5, so here's where 5 is. 2 units away would be 7 or 3. More than 2 units away should be 2 rays pointing in opposite directions, like this. This is what my graph should look like. Now, I'm going to go back to my inequality that I wrote, and I am going to solve case 1 and case 2 to make sure that I'm correct. Case 1, remember, is simply, without the absolute value bars, the same as what you're seeing. X minus 5 is greater than 2. So if I add 5 on both sides, I get x is greater than 7. Perfect. That matches the ray on the right-hand side. Case 2 is where that x minus 5, we need to talk about the opposite of that. Because remember that the absolute value of 5 equals 5, and the absolute value of negative 5 is also equal to 5. So we said that these two numbers inside the absolute value bars are opposites. So the opposite of this might be greater than 2 instead. Now, dividing away that negative sign on both sides flips the symbol and changes our 2 to a negative 2. If we solve by adding 5 on both sides, I get x is less than 3. So that is my other ray. So my graph was correct, and so was my inequality, absolute value inequality. So again, distance means that you are subtracting. So the distance away from 5, x minus 5. The distance away from 8 would be x minus 8. The distance away from 12, x minus 12. So that's how you determine what to put in the absolute value bars. The distance you are away from a certain number. And then it said that you were more than 2 units away. That's why I went with greater than 2. If it was less than, that would be completely different. Remember that when the symbol is less than, it doesn't create 2 rays in opposite directions. Instead, it created that interval, that closed interval, or that open interval, where you had 2 endpoints just connected in between, so it was a segment. Okay, you should be able to finish all of those pages in the packet now that we started.